Welcome to the discussion session on tutorial 5. On this video, we'll try to cover question 3 on slope failures in C5 soil. So, on our question, we are given a slope which represents a typical riverbank slope where on the downslope on the downslope we have a height of water level HW equals to 3 meters. The slope has three different layers: layer 1, layer 2, with layer 3 with three different values of C and phi. There is also a seepage height of HW prime equals to 9 meters within the slope. And we have a slope circle cutting the two extents of the slope with angles delta 1 equals to 19 degrees and delta 2 equals to 42 degrees. We need to find the factor of safety of the slope using the Janbu's 1968 method with the figures A2 to A5 in Duncan's Slope Stability Handbook. So as you can see in our question, we have this HW prime, HW. We do not have directly the slope angle, but we can easily determine this by using this, right? 1 over 1.5. We do not have any upslope surcharge nor any tension crack. That is, no surcharge, no tension crack. But we have the effect of the seepage, right? Which are controlled by this HW and HW prime. Now, coming on to this figure A3, where the submergence and seepage adjustment factor for phi 0 and phi greater than 0 soils are provided, we can go on to our particular circle and using this ratio HW over H or HW prime over H, and using this beta angle, we can interpret for whatever the angle we have, then we can find this factor mu W and mu W prime using the particular circle. So if for our case, if we have a slope circle, then use this. If it is a deep circle, then use this. So from here, we will find mu W and mu W prime. Okay. Now, for our question, if we have a surcharge, then we use this two-factor table, where this is the ratio of the surcharge over gamma H. These are the beta angle. We can find mu Q. But if we have no surcharge, then we will use mu Q equals to 1. Okay. Next, on the figure A4, if you have a tension crack, like here, if you have a tension crack at the upslope layer, usually we have it at the top layer of these slopes due to weathering or or due to the effect of the cohesion. So for this, or there could be waters inside the crack, right? So if we have no water in crack or in a crack filled water layer, then for the particular circle, we need to find this HT over H, where HT is this height of the tension crack, and from there we can find mu T. But if we have no tension crack, like in our question, we have no tension crack, then this mu T will be equals to 1. Now, on the figure A5, which is the slope stability chart for phi greater than 0 soil, we have this equation of the factor of safety, F, that we need to determine, where we need this N over subscript C of F, this C that is coming the cohesion, and this parameter P subscript D. P subscript D we need to find using this equation, where we know this gamma, we know this height, we know that there is no surcharge, we know gamma W, we know HW, we know these factors, right? So we can that determine PD. Again, we can also determine P subscript E, which will help us to get the lambda C phi. So once you know this lambda C phi, we can come onto this graph and use the slope ratio. From there, we can determine this NCF, right? So, but we just need to keep in mind that for our question, we have three different layers of soil, which is a heterogeneous type of slope. So for this, we need to follow the procedure where we need to find the value of the C average, where we know this delta 1, the angle for this particular C1, and delta 2 for this angle particular C2, and over the summation of the angle alpha 1 and alpha 2, right, for this particular two slopes, we can find the C average. So if you know the C average, similarly we can also find the 10 phi prime average. We can use this to determine lambda C phi prime and use the chord B. We can use this too. Using this figure A5, we can determine NCF, and from this NCF and C average from here and PD from our previous slide, like from here, we can determine finally the factor of safety of this slope. Okay, so that's all for question number 3. Thank you so much.